Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is factoring special cases, and we have number one here. What we're going to do is take the square root of the first term, square root of the last term, and then we're going to put this off to the side over here. What I'm going to say is the steps. So the steps are, step one, take the square root of the first term, square root the first term. Step 2, square root the last term. And then step 3, here's the step we haven't done yet. We're going to put it all together. So I'm going to put the answer from step 1 here plus the answer from step 2. And then do it again, but have a minus. So I have 4n minus 3, 4n plus 3, 4m squared minus 25. So I'm going to do it again. So number one, we're done, by the way. That's it, right? 1, 2, 3, and then we're done. So step 2, or number 2 here, we've got the square root of this, square root of that. Square root of 4 is 2. Square root of m squared is m. Square root of 25 is 5. One's a plus, one's a minus. You can do minus and then plus. I did minus and then plus on number 1. So I didn't do it exactly like this, but it doesn't really matter which one you put first. So if I put a plus here and a minus here, it's the same thing. Because you can do like 3 times 4 is the same thing as 4 times 3. It's like that whole kind of thing. So it doesn't matter which one you put first, as long as you get it all in there. As long as you don't have 2 pluses or 2 minuses. We'll have a little bit of that later. Speaking of later, here it is right here. So here, this method, if it's a trinomial, right? So if it's a trinomial, then the steps are just a little bit different. It's easy to get these confused, so be careful. The first 2 steps are the same. Step 1, we square root the first term. Square root the first term. Step 2, we square root the last term. Square root the last term. And then here, so step 3, what we do is we're going to, you put the sign. So the sign of the middle term, basically. So you take the sign of the middle term. Let me write it like this. Take the sign of the middle term. So here we have a middle term. So we need to take that and put it all together. So then we go the first thing, the first term, the sign of the middle term, and then the last term. All quantity squared. So what does that look like? Okay, well, square root of this, so that's 4b, right? Square root of 25 is 5. The sign of the middle term is a minus, and then you square it, right? Square root the first, square root the last. So the first 2 steps are the same, and then the third and fourth step, third step is you take the sign of the middle term and put that in the middle, instead of doing a plus and a minus like you do for the difference of squares. So we do the same thing here. Square root, square root of 4x squared is 2x, square root of 1 is 1, take the sign of the middle, quantity squared. And then we're done. All right, on to the next. Difference of squares again, so square root, 3x minus 1 and 3x plus 1. And there we go. Square root, n plus 5, and minus 5. All right, then we have the next set here. So difference of squares again, n squared plus 10, n squared minus 10. Notice I didn't hesitate here because you can take the square root of n to the 4th power. The square root of n to the 4th power is n squared. Same thing here for number 8. A squared plus 3, a squared minus 3. Right? So we'll move on to the next one. And scroll down a little bit more. Square root, k squared plus 6, k squared minus 6. Again, n squared minus 7, n squared plus 7. Next set. Yellow. Here is a problem that's a little bit different. Now we have a greatest common factor. So I was checking for a greatest common factor each time, but I can usually spot a greatest common factor pretty quickly, so I don't normally, mention that like, oh, hey, there's no greatest common factor here. I did for number 1, but after that I kind of just went with it. But for this one, there is a greatest common factor. If there is, you've got to pull that out first. Because right now, these are not square numbers. 98 and 200 are not square numbers. But if I pull out a 2, aka divide by 2, 98 divided by 2 is 49. 200 divided by 2 is 100. Now these are squares, right? So now I can take the square root of 49 n squared, which is 7n. Square root of 100 is 10. 1's a minus, and 1's a plus. All right. So be careful with that, because that will happen sometimes. Sometimes you factor it and it's not done. You got to like factor it more than once. Do 2 different kinds of factoring. Same thing here for this one. If I take out a 3, I get 1 plus 6 over 3 is 2. And then 3 over 3 is 1, so I have b squared. Now, this looks a little weird because it's backwards. So if I rewrite it so that it's forwards, might make a little bit more sense maybe. I don't know. Probably used to seeing it that way more. And then we can do a trinomial squares thing here. So that's going to be b and 1 and the sign of the middle squared. Looky there. All right, 13 and 14. So here it looks like both of them divide by 4. So I'd have 100 minus 9v squared. And then take the square root of both of them. Square root of 100 is 10. Square root of 9v squared is 3v. And there we go. All right, next one here. Looks like this one does not have any greatest common factor. These are some big numbers, but 81 is 9 times 9, and 9 is 3 times 3. 100 does not divide by 3, so those are not going to have anything in common there, but they are already squares. So I just take the square root. 10x, sign of the middle is plus, square root of 81 is 9, quantity squared, and we're done. Next. We have all of these look like they divide by 10. So we pull out a 10 first. N squared plus 10n plus 25. Right? Square root, square root. That's n plus 5, quantity squared. Next, it looks like that's 49, which is 7 squared. So these are not going to have a GCF, but we can take the square roots. So that's 7n. Square root of 16 is 4. Sign of the middle is minus. Squared, and there we go. On to red. Square root, square root. That's 7x plus 10. 7x minus 10. Be really careful because when it all of a sudden changes, like notice the last 3 problems, 14, 15, and 16 were all trinomials, and then it just, poof, just right back to binomial. So be really careful. Because with the binomial, you have to have 2 different things, right? So maybe think like bi is 2, right? Binomial, 2 terms, 2 different signs. It doesn't work with the trinomial because there's not 3 different signs. But with trinomial, it's like a quantity squared. With the binomial, there's 2 signs. All right, so be careful not to mix up those methods because they're kind of similar. 1 plus r, 1 minus r. Let's see if I can get rid of that. Nope, I got to erase it. There we go. 1 minus r. Okay. So then, change color again here. We're almost on the last leg of this thing here. So we would divide out of 10. And it looks like a variable of p comes out here as well. If we divide out 10p, that's p squared. And then 10p here, that'd be minus 196. Both of those are square roots, 10p, p plus 14, p minus 14. All right, on to the next one. We have 343, which I know divides by 7, but if you didn't know, you could just try to divide it by numbers until you get to 7. It's not going to divide by 2, 4, or 6 because it's not even. It's not going to divide by any even number if the number's not even. Okay, so you don't even need to try those. And then it doesn't divide by 3 because all the digits don't add up to a number that divides by 3. Okay, I won't spend too much time talking about why that works because I don't really understand it myself, really. But it's a method that works. I actually have a whole video on how to do factors and things like that. But anyways, so it does divide by 7. So we want to factor out a 7 and a b squared. So that's going to be 49 minus b squared. And then we can square root. So that's 7b squared. 7 minus b, 7 plus b. And then we're on to the last two here. So we have 81v squared. Oh, look, they both divide by 9, so I can factor out a 9 and a v squared. So then that's 9v squared minus 100. And then those are squares. Look at that. So 9v squared. Square root of 9v squared is 3v. Square root of 100 is 10. So I have 3v minus 10 and 3v plus 10. All right, last one here. Looks like all of these divide by 8. And again, if you're not sure, you can always just kind of go for it and see what they divide by. You could factor tree them all. But it looks like they all divide by 8. So 200 divided by 8, that's going to be 25m squared. 80 divided by 8 is 10m. And 8m squared divided by itself is 1. Then I square root 8m squared. Then we have 5m plus 1 quantity squared. And there we go. So if this has been helpful, you can also grab my free guide on my website, myersmathematics.com. Sorry, that was a little bit fast for a scroll there. You can grab my free guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them on my website, along with some other cool free resources. So go check that out, myersmathematics.com. And if you have any other video ideas, you can put a comment down below in the description, or you can shoot me an email. That's also where you can reach me for tutoring. If you need any tutoring for math from grades Algebra 1 to Calculus 3 or SAT Math Prep. So go check that out, and I hope to see you in another video real soon.